This is Hold's demo video for the Chainlink CRE Hackathon. Our architecture bridges the gap between global liquidity and traditional finance. When a user initiates a borrow, the off-chain orchestrator first secures the collateral by locking it on the Avalanche spoke contract. Once confirmed, an HTTP trigger is sent to the CRE, the Chainlink Runtime Environment. The CRE uses secure signatures to interact with the hub on the base chain, borrowing the required stable assets. Finally, the orchestrator off-ramps these assets and issues fiat directly to the user's bank account. It is a secure, high-speed solution for the future of cross-chain lending. Due to the fact that our CRE workflow has not been deployed on the Chainlink DOM, we can't automate the flow. Hence, we use the local server. I have input the borrow route API params, collateralizing Avalanche native token AVAX to get CNGN on the hub, which is base. As you can see, the call was successful. Now we should be able to copy the params, which includes a signature that was signed by our orchestrator. Now we run the CRE workflow simulate -- broadcast command. To broadcast the transactions on the blockchain, we will choose option 1. To simulate our HTTP trigger, now we paste the params we copied as input. Nice. As you can see, we have successfully simulated and broadcasted the workflow to the hub chain, which is base Sepolia. Let's take a look at the transaction on the Explorer. As you can see, the transaction was successful. If you notice, you can see that our mock CNGN token was transferred to the user. Due to the fact that we currently in the testnet environment, we can't issue fiat, Naira, to the user. Now we repay the loan we took from the hub, base Sepolia. We make a call through the repay loan route. We pass the amount, token address, and loan ID. Nice. We have successfully repaid the loan on base Sepolia. Now we copy the transaction hash to be used to simulate the log trigger. The way it works is that our workflow would listen for the repayment event on the hub, base Sepolia, then send the transaction hash to our orchestrator to verify and return a signed message. The workflow sends the signed message and other params to the spoke contract, Avalanche Fuji, so that the user collateral is released. Now we would select option 2, paste the transaction hash, put in the event index 3. The workflow fetches the transaction receipt, found our loan repayment event with 4 topics: the amount, the position ID of the user, the loan ID, and the chain ID of the chain backing the loan. Right here in the logs, you can the work requesting the whole backend for the repay signature. You can also see the response from the backend. Since WebAssembly has no crypto package built in, we used a special encryption in ensuring only the workflow could request the backend. We also put safety measures in our backend and the contracts to prevent common vulnerabilities like signature replay attacks. Yeah, we have successfully released the user collateral on the spoke. I will now initiate a simulated cron job trigger. This service monitors price feeds for loanable assets supported on our base chain hub that are not natively available on the spoke chain, Avalanche. It then pushes these updates to our custom price feed contracts on the Avalanche spoke chains. This synchronization allows us to accurately track a user's position and health factor directly on the chain where their assets are secured and easily accessible. Success! The price feeds for the spoke chain have been updated. Looking forward to deploying our workflow on the Chainlink DOM. You check us out at joinhold.com.